Core 3 Review Sheet F Differentiation using the chain rule. So let's look at the first question, which is differentiating y equals 2x plus 3 all to the power of 7. I'm going to do this in full using the chain rule. So you start by letting u equal the part that's in brackets, the 2x plus 3. Du over dx, we're just differentiating that with respect to x, gives you 2. Now, we look back at the question and we see that if y is 2x plus 3 to the power of 7 and u is 2x plus 3, then y must be the u to the power of 7, because the u and the 2x plus 3 are the same as each other. Now, differentiating that with respect to u, the usual rules for polynomials, you multiply by the power and reduce the power by 1. So you get 7u to the power of 6. Now the chain rule is that dy over dx equals dy over du multiplied by du over dx. It's like with fractions where the du's would have cancelled out. So you get dy over dx is dy over du, that's 7u to the power of 6, multiplied by du over dx, 2. So 14u to the power of 6. Replace the u by the 2x plus 3 in brackets, and you're left with the final answer, 14, 2x plus 3 in brackets, all to the power of 6. Now, it's very useful with the chain rule to be able to get from the question directly to the differential without having to do all the chain rule working out. Because if you have a question where this is just part of a question, then it can become very complicated if you're trying to show all the method in full. So it is useful in this particular case to be able to go straight from y equals 2x plus 3 to 7 straight to the answer without showing any method. So let's see how that's done. It's called function of a function, the method. What we do is you say it's a polynomial. So we multiply by the power. So you multiply by the 7 and reduce the power by 1. So the power is going to go down to 6. That's why we're going to have a power of 6 here. But also, you have to differentiate the part in the brackets. And the differential of 2x plus 3 is 2. So you do the power, 7, multiplied by the differential, which is 2, so that's 14, and then leave the 2x plus 3, but reduce the power by 1 to the power of 6. So you get straight there, you go 7 times the differential 2, 14, 2x plus 3, all to the power of 6. Now let's try and do that same method on part B. So you've got, again, it's like a polynomial. So you multiply by the power. dy over dx, we can do it directly. Multiply by the power of 3. Differentiate the part in the brackets. So that's going to come to 2x minus 4. And then repeat the x squared minus 4x plus 2, but it's no longer to the power of 3. You reduce the power by 1, so it's now squared. So you go 3, differentiate this to 2x minus 4, and x squared minus 4x plus 2 squared. Let's look now at LUNs. Again, we'll do the first one using the chain rule in full. So you've got y is ln of x cubed plus 4x. So we let u equal the x cubed plus 4x. Du over dx is 3x squared plus 4. Now, y is now, instead of being ln of x cubed plus 4x, we can write it as ln of u. Now, if you had y equals ln of x, and you were finding dy over dx, you'd say it was 1 over dx. So just the same way, if y is ln of u, and you're finding dy over du, you get 1 over u. Replace the u by the x cubed plus 4x, so dy over du is 1 over x cubed plus 4x. Apply the chain rule. Dy over dx is dy over du, that's 1 over the x cubed plus 4x, multiplied by du over dx, multiplied by 3x plus squared plus 4. Now, this is like 3x squared plus 4 all over 1. So think in multiplying fractions, you do 1 times 3x squared plus 4, so that's 3x squared plus 4 on the top, x cubed plus 4x times the 1 that would have been under there, and you're left with x cubed plus 4x. So this is going to be your final answer. Notice it's not got any LUNs in it anymore. And also, look at the quick way to do it. If we compare it with a question, you will see it's called ln of f of x. The f of x bit, the x cubed plus 4x goes on the bottom, and then you differentiate this to get like f dash of x, the differential of this goes on the top. You get 3x squared plus 4 on the top. So the rule for lns is, if you're differentiating the ln, is you differentiate the bit in brackets, the 3x squared plus 4, that becomes the numerator, and the x cubed plus 4x becomes the denominator. So it's very quick indeed. Let's do it this way really fast. So you've got f of x is equal to ln of x squared minus 3, differentiate it. So you would differentiate and you would say 2x there over x squared minus 3. Now I've put it down here as dy of dx is that, but strictly if it's f of x, I'm finding f dash of x, so I should put f dash of x equals 2x over x squared minus 3. So let's differentiate the bit in brackets, 2x, and then the other part, the x squared minus 3, goes underneath. Now let's look at e's. So you get the e's. Now there aren't any brackets here, we're going to do it in full, but let's assume that as if the 7x minus 2 was in brackets. Indeed, you could have written it with a 7x minus 2 in brackets. So u is 7x minus 2, differentiate it to 7, y is e to the power of that, so it's e to the power of u, and just as if you differentiate e to the power of x with respect to x, it stays the same. If you differentiate e to the power of u with respect to u, it stays the same. So, apply the chain rule. Dy over dx is dy over du, e to the power of u, multiplied by du over dx, multiplied by 7. So you get 7 e to the power of u, which is 7 e to the power of 7x minus 2. But notice here, I started with y equals, it was really g of x equals. So I want to find g dash of x, so at the very end I want to change it back, and so I'll say g dash of x is a 7e to the 7x to minus 2. Notice what's happened, of course, is all you've done is you've differentiated the 7x minus 2, 7, and the e bit stays the same. E to 7x minus 2 stays the same. So if, for instance, it was e to the x squared instead, you differentiate the x squared to get 2x, and then you'd go 2x, e to the x squared. The e bit doesn't change. Right. Once we've got to do a little bit more on them, find the gradient when x is 5. So the first thing is to differentiate it, then to slot in x equals 5. This is really quick, this question. So let's do it directly. It's a ln. So we differentiate the bit in the brackets. You get 2x minus 1. That's the numerator. The denominator is x squared minus x, and the ln part has disappeared. When x is 5, you just replace this by 5. 2 lots of 5, 10. Take away 1, 9. 5 squared minus 5, 20. There's our answer. So all we did, differentiate x squared minus x, 2x minus 1, numerator. Put the x squared minus x as the denominator, and then slot in x equals 5. Find f dash of x when f of x is the square root of something. Well, if you see something like this, immediately turn the square root into the power of a half. So you get x to the 4 minus 3 all to the power of a half. Now, treat it like a polynomial. So you're going to do the polynomial rule. You multiply by the power a half. Differentiate the bit in the brackets to get the differential here. 4x cubed minus nothing, so it's going to be 4x cubed. And then we reduce the power by 1. So instead of having x to the 4 minus 3 to the half, it's x to the 4 minus 3 to the minus a half. So to get f of x, to differentiate it, f dash of x, multiply by the power, differentiate the part in the brackets, reduce the power by 1. Now, the answer, well, half of 4x cubed, 2x cubed, and then the rest of it can stay the same. Now, if all you're asked to do is find f dash of x, I would leave the answer like this. But sometimes you need to do some extra work on the question, in which case it's useful to be able to turn this back into a form rather like this. So you can say, well, to the power of a half is square root of, to the power of minus a half, well, if it's a negative index, it's reciprocal of. So that means instead of it being the square root of x to the 4 minus 3, it's going to be 1 over that square root. And you're going to have to multiply that by 2x cubed. So it's the 2x cubed over 1 multiplied by 1 over the square root. So you get 2x cubed over the square root of x to the 4 minus 3. So just look at that again. The 2x cubed is 2x cubed over 1, so that's on the top. And then here, this is the square root of the x to the 4 minus 3, but because it's a negative reciprocal there, you need to say 1 over it, so that's why it goes on the bottom. So that's your answer there. Okay, so good luck with your review sheet.